Right, welcome to the third and final part for today's lecture, unit vectors. So in the previous video, we talked about how we can use components to write out our vector instead of having a magnitude and an angle. And the reason we're going to want to do that is because we're going to start adding different vectors together, and x, y, and z are completely independent from each other. So a unit vector is going to be a way for us to go through and write out our vector with x, y, and z separately without having to get really weird with it. So a unit vector is a vector with a magnitude of 1 that points in a given direction. So that given direction is going to be x, y, or z depending on which unit vector you are using. So this here is a schematic of the unit vectors. So here we have our x direction. A value of 1 points the unit vector I. In the y direction we have j, and in the z direction we have k. So this is what it looks like. So when we want to indicate a unit vector, we add this little thing called a hat on top of it. So you have I hat for the x direction, j hat for the y direction, and k hat for the z direction. So if we recall from the previous video, when we had a vector a, we had vector ax plus vector ay plus vector az. Now what happens when we have numbers? We can't just say 1 plus 2 plus 3 because we know numerically that's 6. So unit vectors are a way of taking this vector ax and saying it's a number in the x direction. It's a number in the y direction. It's a number in the z direction. So the unit vector is giving it the direction, whereas the numerical value is giving it a magnitude number. So we can break up our ax vector into ax I hat, where ax now is a numerical value. So in the example we did at the end of video 2, we found values, and we said this is the value in the x direction and the value in the y direction. Now we would be able to take those values, add I hat, j hat, and then we could say this is another way to represent vector A. So vector A can be represented like this. So now AX, AY, and then AZ, all of these values here, we use a different color, AX, AY, and AZ here, all are going to be magnitudes. They're just going to be numbers. By having a negative sign in front of it, that just tells you instead of pointing in positive x, y, or z, it points in the negative direction instead. So we have magnitudes. This I hat, j hat, k hat give us the direction for our vector. So now we have the two representations of a vector that we can have. We can have a magnitude and an angle, but with the angle we need to make sure it's accurate with which axis we're describing it with. Or we can use this vector notation ijk with the little hats to say this number, this amount of number in this direction. And this is going to allow us to start adding multiple vectors together. So the vector math we're going to be focusing on right now is just this. As we work our way through the semester, we're going to see two other types of vector math appear, but we're going to get to those when we get to them. I don't want to introduce them now. So right now, we're just going to be adding and subtracting vectors with each other. So what happens in x stays in x. So anything with an I hat only can interact with I hat. J hat with j hat, k hat with k hat. We cannot add an x value and a z value together. It does not mathematically work out because we're working in totally different directions. So we can't just add randomly some values together. When we multiply it by a scalar, so let's say we have some vector and we want to multiply it by 2, we multiply all of the values by 2, or whatever the scalar value happens to be. Primarily what we're going to be doing is dealing with adding and subtracting vectors. So let's go ahead and let's practice that. So this is number 44 from the back of the book. So let's read the question and look at the picture and see kind of what's going on. So we have 4 forces. If we look at our diagram over here, we do indeed have 4 arrows. We're starting with this downward pointing one, and it moves around when it comes to labeling in a counterclockwise direction. It says the net force, so the net is the sum of all of the forces acting on this object, is 4.0 I hat. I hat again being the x direction. So the net force of all of my vectors together is 4 in the x direction. So it's asking us what is the value of force 3 and what is the value of force 4. So what I'd like you to do is pause the video and think about how do you set up this question? What are the steps you need to do in order to go through and solve this particular question? If you want to go through and try to solve it, go ahead, but just set up the question. That is all I'm asking you to do right now. All right, so let's figure out what's going on. So F1 here is in negative y. F3 is in positive y. And F4 is in negative x. F2 is different. It's in positive x and positive y. So when I'm trying to find the value of my force in a given direction, force 2 has components in x and y. So the first thing I'm going to want to do is figure out my components of force 2. So force 2x is going to be equal to force 2. So the magnitude of force 2, which happens to be 6 newtons, multiplied by, if I look at my triangle, x is going to be adjacent, so it's going to be cosine theta. For my y direction, if x is cosine, it's better be sine theta. Now, personally, the best way to go through problem solving in physics so you do not get rounding errors is to leave these as they are until you're ready to plug in numbers in its entirety. And the reason this is good practice is this way you're not going to accidentally get rounding errors and you have one less place you can screw up writing down numbers. I am really good at mixing up numbers. It's not a talent I should be proud of, but I'm really good at it. I'm great at accidentally flipping the order of my numbers around. Because I might be looking at a number further down the line and I just write it where it's not supposed to go. So I like to keep them as this for now. And when it comes to plugging in numbers, I just do it all in one step. So that is where I'm going to leave this right now. Part A asks me to find the value of force 3. So for force 3, I want to find the value. Well, force 3 is in the y direction, so I need to use the information in the y direction. Now this is really beneficial because if I look at force 4, which I also don't know, it's not in y. So I can ignore my other unknown in its entirety. So what I need to do is go back and look at my net force. So if I look at my net force, it's all my vectors added together equals 4i hat. So this is only in the x direction. So that means that force net y is going to be equal to 0. There is no value in the y direction once I add up all of my forces. So what does that look like? Well, we need to go to the next slide to do that because I'm running out of space. So I have force net y is going to be equal to force 1 in the y direction plus force 2 in the y direction plus force 3 in the y direction plus force 4 in the y direction being equal to 0. There is no value of force 4 in the y direction, so I can ignore that moving forward. So here I can plug in a little bit of, I'm going to rearrange my equation and isolate force 3y. So force 3y, which is the same as force 3 because it's all in the y direction, is going to be equal to minus force 1 in the y direction minus force 2 in the y direction. So I've done all of my algebra first. Now I'm ready to plug in some stuff. But first, I want to make sure not all of force 2 is in the y direction. So I'm going to need to put in that force 2y sine theta. Now I have everything arranged such that I can plug in my numbers. I don't have to do any more algebra. As soon as I plug in my values, I have my solution. So before I do that, I just want to re-explain what I've done. We're solving for force 3, which in the picture is only in the y direction. Because of that, and I'm only going to be dealing with all my force values in the y direction. When I was in the question, I'm given the value for the net force in x and y once I add them all together. Y happened to be equal to 0. So I've rearranged my equation such that my force 3 is isolated by itself on the left side of the equation, and everything else is on the right side of the equation before plugging in numbers. I'm now going to be able to do that. So I have minus the value of force 1 is going to be negative 5.0 newtons because it is pointing in the negative y direction. So it has a value of negative 5 minus the 6.0 newtons of force 2 multiplied by the angle, or sine of the angle, which is 20. Now going through and plugging this into a calculator, we're going to have 5 minus 6 times sine of 20. We have a positive answer. And this is great because force 3, when we look at that picture, is pointing in the positive direction. So that means that the picture is accurate and we do indeed point in the positive y direction. So I ended up getting 2.9479 newtons. So this is force 3. And again, we are being asked to solve for this in terms of components. So when I go to write out my final answer, first off, everything was given in terms of 2 significant digits. So force 3 would be equal to 2.9. The reason it is 2.9 is I need to look at this 4 when I'm rounding. I don't round multiple times, I round once. So 4 rounds down, so my force 3 is 2.9 newtons. The way the textbook likes to do it is then draw it in, put it in parentheses, and then draw the unit vector. So in this case, because it's in y, it would be in J hat. You don't have to put the parentheses if you don't want to. That's just how the textbook is going to be doing it. So we did it. We have solved for the unknown value of force 3 because we know that the y direction only influences the y direction. So we could use everything related to y to solve for our answer. Part B is similar, however, now we're going to only be using the x direction. Because in part B, we are being asked to solve for force 4. So force 4 is in the x direction and in the x direction only. So we can only use the net force in our x direction. So that's going to be force 1x plus force 2x plus force 3x plus force 4x. And if we go back to our original question, it says that the net force is equal to 4.0 newtons I hat. So our answer is going to be 4 newtons. Here I'm not putting the I hat because everything is in the x direction. So I know it's all associated with x. I'm just going to tack it on at the end. If we go back to our picture, we could see that force 1 and force 3 are purely in the y direction, so they have no x component. So that means we just have force 2x plus force 4x being equal to 4.0 newtons. So we want to rearrange to isolate 4x, which again is just equal to 4 because all of it's in the x direction. So we'll have 4.0 newtons minus force 2x. So again, remember that force 2 is not just in the x or just in the y direction. So we need to go through and plug in our equation. So force 2 cosine theta. So now if we plugged in the information we have about force 2, we'd be able to go through and finalize solving force 4. So again, I just want to recap what we've done so far before we get to that step. For part B, we're solving for force 4. It is purely in the x direction, so we're only using x direction information in order to go through and solve. For vector 2, part of it is in x and part of it is in y. We already used the y direction information when solving for force 3. So we don't need to include it here. We only want the x component of force 2, thus needing that cosine theta portion. So that's going to be 4.0 newtons minus 6.0 newtons cosine of 20 degrees. Taking that and plugging it into a calculator, I got negative 1.6382 newtons. Again, this negative sign here just indicates it's pointing to the left, which agrees with the image that we have. Force 4 points to the left, so we should have a negative number. Now the question did ask us to have it in components, so that means that we can say that force 4 is equal to negative 1.6 newtons, because again we were given 2 sig figs for all of our values, so our answer should have 2 as well. All right, so that's going to wrap it up for today's lecture. Again, as we go through and introduce new ideas, some of the stuff we are going to cover again, it just won't be in as much detail. So this is just kind of a good reference lecture to kind of come back to if you have questions. But yeah, if you have any questions about the lecture, let me know. And if you haven't taken the lecture quiz already, now is a good time to do so.